All right. I'm excited to have my friends Jim Fultz and Jim Hagl here from Copeland. I'm so used to saying Emerson. I'm probably going to say it a couple times here, but it's exciting to get to be able to say the Copeland brand again. I think that's the one we all cut our teeth coming up on. So it's really cool to kind of have that back and front and center again. And so we're going to talk through that and a bunch of other stuff. We're going to talk about filter dryers, suction dryers, liquid dryers, system cleanup, all that stuff. But before we do that, I want to give you each a chance just to kind of introduce yourselves, tell us a little bit about what you do with Copeland. So I'll start with my good friend, Jim Fultz.
Hey, thanks, Brian. Thanks for having us on today. Always a pleasure visiting, chatting with you here, and great to be talking about filter dryers today. Jim Fultz, my name. Title is Technical Training Specialist here at Copeland White Rogers, and I help out on the heating side of things mostly, and so that's why we kind of tag teamed here with our cooling partner on the cooling side of things to go through those together today.
Awesome. Yeah, thanks for joining us. And now Jim Hagl. We got two Jims with us. So when I say Jim, they're both going to pipe up.
Yeah, we can just go with first letters of the last names. But
okay.
So I'm Jim Hagl. I've been affiliated with dare I say the word Emerson for 35 years. So currently a lot of different roles, but currently I'm in charge of all of our wholesale sales for the cooling control sector of our business for our portfolio. So and we're all kind of learning our new a lot of changes going on besides just the name change.
Yeah, I bet.
So we're getting used to that.
Yeah, for sure.
But happy to be with you.
Yeah, it's exciting. So I'll let you kind of talk about that because you already mentioned it. So a lot of people may not know this. Brand realignment, Copeland is the name everybody's going to hear a lot more now. So what should we expect? What's that all about, and what are we going to see in the near and maybe distant future?
Well, I think, again, this is just going to be a fight between Fultz and I on who's going to speak first. But anyway, but there's a lot of excitement about us being a standalone company, kind of breaking away from the traditional Emerson platform and being a standalone with Copeland as our name. Obviously, well respected for, oh my gosh, let's think 100 years or so.
Yeah.
Yeah, we're excited about it. Carries, the name I've been with even before Emerson. I've been with White Rogers, been with Flow Controls, been with Alco. So there's been a few changes along the way, but this change is really being embraced well by everybody. So we're excited. Gosh, again, once the dust settles, we'll feel a lot better about everything. As we'll talk a little bit more later on about trying to find some of our stuff. It's all a work in process right now, trying to get our websites and everything back up and everything functioning great. But everybody's pretty excited about it. Being a standalone company is going to definitely open some doors and allow us to invest more in the company. So from that standpoint, we're pumped. So.
Yeah, for sure. It's going to be interesting, like you mentioned, because a lot of the products were used to asking for an Emerson dryer, for example, and now that's going to change. So, Jim, what are you seeing on your end, Jim Fultz?
I think Hagl covered it quite well. It's just a matter of the process of working through this. As far as the products themselves, they're going to continue to flow uninterrupted. So, as far as seeing the product come and be available, I don't know that you will even see any hint of any change in that whatsoever. As far as the actual rebranding of things, that's the part that there's still discussion and talk of exactly how those names all fit together. And the example that you gave of the Emerson filter dryer, and obviously the Emerson name will be no longer affiliated with that. What group or name it is attached to, that's, until we know, we really don't have much to share on it, because
right.
We have the Sensi name as well as the Verdant, which is a thermostat based out of Canada that was an acquisition a couple years ago. And then the Copeland name, as well as the White Rogers name. And so how those names are all used currently, well, go back here to last year, Emerson was the umbrella that all of those names were under. The acquisition that took place started a new company, and I like to hear it as we are a 5 billion startup. So lots of opportunity, but how all of those names fit underneath the Copeland as the overarching company name, we'll see those rebranding effects here probably within the next year, hopefully sooner. But it's taken some time to get there.
Yeah, of course. I mean, it's a big ship, so there's a lot of things to work through. All right, so let's dive into the topic of the day, which is filter dryers and the filter dryer line. So let's start there. What are some of the different types of filter dryers? Start real wide, and what are some of the different categories and subtypes? Whoever wants to take that.
Wow, that is we could spend an hour just on that one question, but let's. So when you're talking filter dryers, as a general rule, when you're talking the refrigeration aspect, you have your liquid line, you have your another classification called the biflow, which is also located in the liquid line, and then you have your suction line dryers. And then we also get into a whole nother WebEx talk about oil dryers and some other specialized dryers. But let's just keep it to these refrigerant dryers, and I'll kind of go through maybe our batting order, if you will, of our primary dryers at Copeland here. So from a liquid line perspective, I look at it from a liquid line. We have kind of like 4 main liquid line dryers. A biflow, we have 2, and then the suction line, we have 4. So, and if you want me to, Brian, I'll just give you a brief kind of overview of those.
Yeah, sure.
Is that good?
Yep.
So we have our bread and butter, our wonderful EK, the industry's best filtering dryer. And when you say filter dryer, it filters and it dries. There's nothing better out there than an EK filter dryer from the filtering aspect. Everybody's kind of dries pretty much similar, but from the filtering aspect, we can filter down to 20 microns, which is the finest filtration in the industry. So, but our EK is our kind of our premium. It's like I said, filters down to 20 microns. It can capture and hold up to 13 grams of grit, which is quite a lot. Where most like block style dryers, they filter to 40 microns, so not quite as small, and they can capture and hold about 8 grams of grit before they get to that pressure point where they need to be removed. Pressure drop point where they need to be removed. So our EK is our kind of our bread and butter. It's the I guess it's not the Cadillac, it's the Tesla, I guess, out there. So and then we have what we call our Builder Series line. It's a little more economical. Like our BSL, Builder Series Liquid. It's still got that compacted bead design, still filters down to 20 microns. It's a skinnier diameter liquid line dryer. So it removes the same size particles, but it removes just a little bit less as far as volume, total grams, and it removes just a little bit less as far as drops of moisture. Now, when I say less, we're talking maybe 25% less. And let's be honest, for the most part, filter dryers, unless there's a catastrophe, you're not going to get into to max it out on drops of moisture. I mean, we're talking, and I'm just going to shoot off the cuff here. We're talking an EK maybe hold 163. Will probably hold about 150, 160 drops of water. That's a lot of drops of water an EK can hold. The Builder Series version of it, which is kind of like the mini EK, if you will, is probably holds 75% of that drops of moisture, maybe 120 drops, somewhere in that ballpark. So it's a little skinnier diameter. So, but I know some contractors get a little nervous when they see these out at wholesaler shelves or whatever, because of the diameter of the shell is a little smaller. Well, they think, well, that's not going to flow the same amount. Well, it's an interesting perspective, but the capacity of a dryer is not only the size of the shell, but it's relegated to the size of the connection as well. So a 3/8 dryer, that's 5/8, 8, an 8 cubic inch, a 5 cubic inch, and a 16 cubic inch could all flow the same capacity because it's it's mandated by the 3/8 inch connection, not necessarily the volume of the dryer. So there's some myths out there and some nervousness that a smaller dryer like that might, raise some questions. The good side of on a builder series, a smaller diameter shell, is it fits easier into tighter spaces. So some contractors love that aspect of it. Still flows the amount of refrigerant, but it's easier to sweat into a smaller configuration. So anyway, so we have the EK, which is our Tesla. We have the little more economical BSL. Then we have a couple other specialized dryers, which are like our BOK. And I would love to get in a little discussion later about the BOK. It has the HH desiccant. So it's HH is a acronym that's used in the industry to tell you it's got activated carbon in there for burnouts and stuff like that. And maybe we'll shelve this conversation till a little bit later in the talk. But that's our burnout. So the BOK stood for burnout clean when we came out with that. Burnout clean. So EK was extra clean. BSL is builder series liquid. Then we have the BOK for, it's really a temporary dryer for burnouts. And then the other specialized dryer we offer is on the liquid line side is the CU, which is our copper spun dryer. So we make two different types of copper spun. We make the appliance type dryers for beverage machines or refrigerators, Coke machines, stuff like that. Yeah, but we also make it in regular 8 and 16 cubic inch filter dryers, which we have a really nice handout and flyer that we sell our CU 163S and CO 83S, especially in coastal applications or marine applications, that it's 100% copper. Why is it 100% copper? Because it's corrosion resistant, so it's really targeted along those coasts. An interesting thing, when we launched this product some years back, I looked at the Statue of Liberty. The Statue of Liberty is 100% coated in copper, just from the rusting aspect, so it's not rusting. So, but a CU dryer, I mean, we've all seen it if you've been out in the field. Dryers, man, they rust in a heartbeat if they're out in the ambient. Woo, boy, it's crazy. So those are our basic 4 liquid line dryers. From the BiFlow side, we only have 2. We have our BFK, which is our industry kind of leading. We've just done phenomenal over the many decades as far as shares as that goes, as the industry leader with the internal flapper design of it. So it's a BFK, it's a BiFlow filter dryer. It'll flow in both directions, but yet it will capture and hold the grit inside the dryer itself. And then we have the BSB, which is our builder series version of that. Again, more economical, a little bit less on the diameter and a little bit less on the desiccant that's inside of there. But again, when I say less, don't panic. It's not that much less. And then from our suction line, which, suction line dryers aren't as common as liquid line, obviously, because, they're really in there for safety net when you've had a system issue. So we have the ASD, which is our premium liquid or suction line dryer. It's got the most desiccant in it could possibly have. Then we have the SFD, which is a smaller version, kind of the more economical. Some people refer to the SFD, maybe call it a short fat dryer. But then we also have the CSFD, the compact suction filter dryer, which is like the pancake dryer. Again, when you need a suction dryer and you don't have, and you got, again, a little bit of space, industry calls them pancake dryers. That's the CSFD. And then we have the ASK, which is the one that has activated carbon. So it has the HH suffix on the model number. So again, that's for definite burnout installations. You would want to put that in as a temporary fix and then get it back out once the system's been identified as clean. So those are, that's probably our I just went through the top 10, 4, 2, and 4 of our batting order of filter dryers in our portfolio.
You covered a lot of things that I was making some notes on there that I want to touch on, and then Fultz, I'll kind of get some of your comments on it. One of the things you mentioned was the copper spun dryers, how they're great for environments where corrosion is advancing. It's going to happen more quickly, and in fact, you see spun dryers in a lot of manufacturers' equipment. So when you open up the condenser, a lot of times spun dryers are what they put in from the factory for that reason, probably because you don't have as much control over where they're going to be. But I would want to hear, because one of the things I've always said, and some manufacturers say this, others don't, but I've always said, where possible, put your liquid line dryers on the inside where they're going to protect the indoor metering device and they're going to be out of the elements. There's some debate about that, but there are some factors in where you place liquid line dryers. So I'd like to hear, I mean, just because it kind of came up in a couple different areas there, if Jim Fultz, if you have any thoughts on that.
Yeah, I'd be glad to share with that. And there has been debate in the past of exactly how that's done, where they go. And I like to take it from the aspect that we're going to stop and we're going to think about what we're wanting to protect. And the main thing that we're looking at is we are wanting to protect the metering device. We're wanting to keep any type of debris to get into that metering device and cause it to malfunction or to be completely restricted. And so the placement of that filter dryer on the liquid line side of things is going to be critical of getting it where it's going to do the maximum protection. So if you're installing a straight air conditioner, not a heat pump, straight air conditioner, your metering device is on the inside, and the ideal spot is right outside that indoor coil, right close to the TXV. So it's doing the maximum system protection of protecting everything all the way back from the condenser to the TXV or whatever type of metering device is there. Now, the exception to the rule that I would prefer would be if you're installing a heat pump and you are installing it in the wintertime and you're going to do the startup in the heat mode. Now you're going to be using the TXV or the metering device in the condenser in the outdoor unit. And in that application for a startup in the heat mode, my preference would be to see that filter dryer, which is going to be a biflow at that point, out close to the condenser, so that again, it's going to be at the point the closest to that metering device to do the most protection that you can get from throughout the entire system. And so if you're going to do a heat pump and you're going to start it up in the cooling mode, I'm perfectly fine with it being on the inside. So inside is really the majority of your applications. If you're primarily AC, if you're doing heat pumps, then decide what you're going to start up and what mode you're going to start up in and do your placement from that. That's the liquid line side of things. The suction side of things, and we'll probably get a little more into why and where with suction filter dryers, but those the ideal place for those is again where they're coming back to the compressor, doing the maximum protection against that compressor, and that's going to be outside close to the condenser. And you say, well, the most protection for the compressor is in the condenser, in the tubing inside. Well, if you're right, that is the best place as far as placement but for practical application, if you place it outside the condenser, then you can use the service valves, the king valves on the condenser to pump the refrigerant down into the condenser when you go back 24 hours later to remove that suction dryer without having to reclaim all the refrigerant. So best placement practice for the suction filter dryer in those burnout situations is right outside the condenser there on the suction line.
Yeah, there's so many different factors. One of the things, and I want to mention this, we've got 81 people watching right now. Any of you can ask questions as we go along. Freon Leon is the name he put, and it's a pretty funny name. And he said, he made a good point. He said, so always start up an AC. So you could do that, right? If you're in a situation where you had reason to put the liquid line dryer inside, maybe you're in a corrosive environment or whatever the case may be, then you could actually start it and run it for several minutes in AC mode first.
Yep.
And then that would kind of cover that. Now, again, there's a lot of reasons why people don't like to put it on the inside. You may not want to bring your torches in there, depending on where you're doing the work. There's lots of factors. And I think you got to think through all of these things. Another one of the factors that gets mentioned a lot is that Emerson, or in this case, Copeland, I'm going to keep doing that, mentions that locating your liquid line dryer in a cooler location is also preferred. Is that right still?
Absolutely. Yeah. The desiccant, the inherent property of desiccant is it absorbs more, it performs better in a cooler location. So yeah, you drive by it, you go by a Starbucks or something, you see a dryer sitting out there just baking in that sun, that I think those stupid thoughts, if you will, but the desiccant is designed to operate at its peak performance in a cooler location. So that is definitely one reason why you should take it the extra step, get it as close as you can to the expansion valve, if like Jim referred to, and put it inside. So.
And I've had people mention, it's funny how far we've fell down this rabbit hole in social media. So I had somebody say, but what if your fan coil or your evaporator coil is in an attic? Well, so now the attic might be warmer than it even is outside. So there's all these different factors to consider, and just looking at your application. But we know it needs to be in the liquid line, and we want it to be as close as possible to the metering device it's going to be first protecting. We want to keep it cooler, and we want to keep it protected from the elements, if at all possible, just to increase its life. But again, we don't ever want to make the perfect the enemy of the good. Most important is to get it in there, replace it every time we open the system, and we're gonna talk more about that.
Yeah, and
I obviously go ahead.
I don't think that can be said enough, that get one in there. Every installation, if you go out to a job and there's no filter dryer inside, outside, anywhere, it's unfortunate that is occurring even yet today, because they need to be in there. Now, am I going to tell you to go ahead and just open it up just to do that? No, I don't know that that's going to be beneficial if the system's been running several years and you're good to go at this point. But yeah, anytime that system is touched and opened and there's not one in there, that needs to be verified and get one in.
Absolutely. Let's move on to the question of selecting and sizing a dryer. So now, obviously, we're talking, we could go into the whole world of core dryers and all that. That's not really what we're talking about mostly here. We're talking about selection of dryers in residential, light commercial, HVAC, maybe some refrigeration applications, but the smaller sized ones. How do you go about picking the right dryer?
Well, I listed 10 different dryers there. So you obviously need to know your application, any sort of system issue that you've had that you need to address, whether you tested the oil and you got acid and all that kind of stuff. But as a general rule, from the Copeland perspective, from a liquid line, we're going to tell you go to the EK or the BSL as a standard, do your best all in one kind of dryer. And then if you have those certain issues, then you look at going if you want to put in a BOK or something like that. And again, the suction side, all these things are really, they're commonplaces we have the one main dryer, but then do you have enough space to put something in? Do you have enough, are you trying to fix a certain problem? But as a general rule, from the Emerson perspective, you use the EK. Suction line, you would probably want to use the ASD or the SFF. Again, just depends on the price. So it's that's from the selection of it. From the sizing of it, you need to know what the refrigerant is you're dealing with. Any sort of special applications where you're operating temperature wise, obviously air conditioning plus 40. And we kind of size that. We make it simple. We put it on the boxes. But even in our catalog, like the liquid line dryer, we only put, whoa, look at that, 3D. Beautiful. We put it in a catalog. We list it as both 1 and 2 pound pressure drops on the liquid line side. Because the liquid line dryer, you want to kind of keep in, it's doing its job until you exceed really 3 PSI pressure drop. So we size it on the box, I think at 2 PSI, but we put it in a catalog at 1, kind of in our catalog for the OEM purposes. So OEMs can look at it, but general rule is we size it off at 2 PSI from the liquid line side. On the suction line side, we don't size off pressure drop. We don't want pressure drop in the suction line size. So we base it off of your operating temperature, where you're, what you're dealing with, whether it's, where you're at. So that's how you kind of size those two. But, I do want to, I think I may have mentioned this briefly, but I do want to point out when you're sizing dryers, again, you need to know not only the cubic inch of the dryer, but you also need to know the connection size. So you got to, because like I said, a 3/8 inch filter dryer could be on an 033, a 3 cubic inch dryer could be an 053, an 083, a 163, and yet the 5, 8, and 16s are generally flowing about the same amount of capacity. So, but the best bet is to look in the catalog, look on the box, because on the box we put different sizing models on there based on the dryer that's in that box. So, on a 16, we only put the 16s on there. But as long as you pick that up and look at that, if you're in a wholesaler shelves. But just be leery that don't base it off one or the other. I need a 5-ton dryer for 410A. Oh, I got to go 163S. No, if you don't have one, if you got an 083, that's going to do the job for you. So those are just kind of some things to think about.
Yeah, you got to know what refrigerant you have. You have to know the size of the connection. You have to know the capacity of the equipment that you're working on. You have to know, is it going to fit? You can't get some gigantic suction dryer if you don't have space for it. And you need to know why are you putting it in? Are you putting it in just because you opened the system for regular service, you installed a new piece of equipment, or are you putting it in because you had some event with the equipment, something bad happened that now you need to potentially clean up? That's kind of my basic categories there.
Yeah, I kind of divided it into 4 new installs where the line set and everything is brand new, and you got new refrigerant. And then you have the retrofits where you may be keeping the line set and flushing it out. There may be a benefit of having a little more size there, especially if you're going from a 22 mineral oil to a 410A POE oil. Then you have the burnouts where you're going to have specialty dryers, and then just simply the opening of the system for regular maintenance. And to finish up that size wise, Jim was talking about a 083 or the 163. Those first 2 digits is the cubic size of the filter dryer. So you have the 8 and then you have the 16. The 16 is by far the most prevalent filter dryer that works. You can put it into a 1.5. You can put it into a 5-ton. Do you need that large of one in a 1.5? No. Up to 3-ton, and you'll see this on the box. You can use that 8 cubic inch, and then from above 3 go to that 16 on the liquid line size. So and then the clarification of that as far as the flow, the larger the tube that's connected to it, the more flow you're going to get through it. But typically on your 3/8 liquid line size of tubing, which the majority of what we're going to see out there in residential heating air is going to be, that 8 is going to be good up to 3, 16 up to the 5. So just trying to make sure that was clear, and that I think it's been covered. You both have done great on that.
Yeah, excellent. I mean, again, and so kind of what you're saying is if you get a 16, then you're going to be safe pretty much most of the residential equipment that you'd ever work on. If you're keeping 8s on your truck, just don't pull that off when you've got a larger piece of equipment, because it's probably going to be too small at that point. Sounds good. All right. So one of the biggest questions out there is, when should you replace a dryer, and what indications do you look for of when a dryer needs to be replaced? I mean, the first most simple answer, of course, which is giving away the lead, is that you replace the filter dryer anytime that you open the system for service. And that's specifically liquid dryers we're talking about here. But let's cover the whole gamut. We've got liquid, we've got suction. What are the cases that we need to either add or replace a dryer? And I'm going to pull up one of the slides here that kind of covers this, just to kind of make it easier for people to follow along.
So sure. Yeah. Okay. So, and I'll just walk down this slide here. So it's obviously due to, first and foremost, to be due to pressure drop, which is primarily what you'll see out there. Again, A solid core will capture and hold about 8 grams of grit on a 16 cubic inch. And, as it's capturing and holding that grams of grit, that's when that's exceeded its capacity. So in an EK, it would be 13. So it can capture and hold a little bit more. But I like to say it, when you exceed 3-pound pressure drop in the liquid line, you need to remove that filter dryer. It has done its job, and it just finished its meal. It's good. It needs to get some rest. So that's easy to say, 4-pound pressure drop, get it out, or greater than 3. But when you put it in real terms, the liquid line is different than the suction line. Suction line dryers have pressure taps typically on each side of it. So it's easy to hook up your gauges and find out if you got a pressure drop going across it. The liquid line doesn't have that. You don't want to put taps in the system. You don't want to do that. So I know some techs that have been around a long time can just do the hand test and kind of get that feel. But basically, a rule of thumb, Jim, correct me if I'm wrong, but probably about 4-pound pressure drop is ballpark about a degree.
It is. Yeah.
So if you can put
on 410A, yeah.
On 410A. So if you put a couple temperature probes or sensors or on there, clamps, and you see you're nearing a degree temperature difference between the inlet and the outlet of that filter dryer, I think it's time to invest a few minutes and change that puppy out. So that's on the liquid line side. On the suction line side, again, you don't want any pressure drop going through the suction line side, because you don't want anything condensing and getting moisture back to that liquid back to that compressor. So we state, at 2 psi, go ahead and change out that suction line filter dryer. And then you get into the discussion of, do you leave it in a suction line dryer permanent? I know if you have like big shells, we recommend you can even leave them vacant or just put a filter in there, not necessarily a filter dryer, but you have to kind of weigh all those. Look at your system on an individual basis and realize what you need in that. But as a general rule, suction line dryers aren't, I guess they're frowned upon from the residential side. And they're only really good for the supermarket refrigeration cases where they have other bells and whistles, other insurance policies, low pressure cutouts, and all that kind of stuff to send a signal or alarm that you've got an issue going on in that suction line side. So that would be the one case you get, I guess the primary case you look at. A system is not needing anything done, but looking at your gauges, you're picking up an excessive pressure drop going either through the liquid line or the suction line side, and that dryer needs to be is the reason for it, needs to be replaced. The other big aspect would be if for some reason you've got too much moisture in the system. Obviously, you would need the moisture indicator would be the way to find that out. So again, on the refrigeration side, that's pretty easy to figure out. If you've got your moisture indicator showing wet, you don't need to replace the moisture indicator. You just need to replace the filter dryer. Once that's installed, run the system, and it should reactivate the moisture indicator. So you don't need to replace that. But that would be the three, in my view, the 3 times you need to replace a filter dryer is anytime you're changing anything out in the system, as you said, Brian. And then 2 would be excessive pressure drops either in the liquid line or suction line. And then number 3 would be if you do know for a fact you have moisture in that system, either through the moisture indicator or if you can get an oil sample and find out you've got some acidity in that oil, it needs to definitely be replaced. Jim?
Anything else, Fultz?
Yeah, well, no, I just reiterate on the liquid line, a very simple visual. I like the visual side of things. If you ever go out to a unit that's running and you see frost on that liquid line filter dryer, pull it out. If there's frost on there, you got some restriction in there, and that's a dead giveaway. And if it's got frost on it, more than likely you're well above 4 psi on your pressure drop on it. Yeah, if you have temperature probes that go to less than 1 degree, that you got a decimal point on your temperature probes, that's a very nice way to be able to test on each side of the liquid line. Suction line side of things on the residential side, 24 hours is the most that really should be in there. You really need to be pulling that out after you've put it in for the burnout. And I'd like to qualify that too. You put it in and 24 hours later you pull it out and the unit never ran in that 24 hours, you've done no good. So you need to make sure after you have replaced a compressor and a burnout and you have put that suction line filter dryer in there, that you do run the equipment and make sure that it's getting several hours of operation, 2, 3, 4 hours plus of operation to be able to run that refrigerant and oil through that suction line filter dryer and get it so that any of those contaminants are held in that when you come back a day later and pull it out.
Yeah, there's so many different mindsets as it relates to this question. And it has so much to do with what part of the industry you came from, right? What parts of the industry you've been exposed to. Because in residential, so many times, well, I mean, in the past, a lot of people didn't even put suction dryers in. They didn't even think about it, right? And then you're like, well, I'm trying to do a good job. And so they put it in and then they leave it in and never come back. So that's the second most common. And then the third most common is doing kind of what you say. You let it run for a while and then you come and you pull it back out. But then when you run into heat pumps, you know, now you've got to make sure you put it in between the reversing valve and the compressor. And sometimes that's very difficult to do. And so a lot of additional cost gets put in there. What I see a lot of people do nowadays, again, I'm in a heat pump market, is they'll put it outside of the equipment and they'll just make sure it stays locked in cool mode during the time that it's operating. But to your point, if the season doesn't allow for it, then you've got to consider that factor. Ultimately, you do not want to. I don't think this can be overstated. And this is true in my company. We're weirdos. We do market refrigeration all the way down to residential. So we get to see all these different sides. But you do not want to leave a restricted suction dryer in the system because of what it does to the compressor's operation. It results in high compression ratio because, again, when you think of compression ratio, if you reduce the absolute suction even slightly, that greatly increases the compression ratio, especially in refrigeration applications. And that makes for massive inefficiency, compressor overheating, all kinds of things that are really bad for the system. So you can't leave plugged suction dryers in there, which is why you've got the pressure taps, right? So at very minimum, make sure that you're not running a plug dryer in there. And the best practice is what you said. I mean, you really do want to get those out of there as much as possible. We're going to talk a little bit more about the different types, you know, sort of HH versus SFD kind of in here in a second. But I do want to get to a couple little questions that have come up. One question that's come up a couple times here already is, what about charge compensation? So do you need to, if you go to a larger dryer or you go to a system that didn't have a dryer and you add one, is there any rule of thumb that you would go to or anything you would say about adding additional charge?
Not unless you're in a critical, very critical charge situation. You know, as long as you go up kind of one size is the kind of rule of thumb. If you go from an 8 cubic inch to a 16, you're going to be, as a general rule, you're going to be okay. Or if you choke down even an 16 to an 8, you're going to be okay. But you know, unless you're in a critical charge, and if you are in a critical charge situation, we have it in our catalog as to, you know, how much more refrigerant you need to add for the filter dryer you're putting in there. So you'll have to refer to the catalog for that step. So, but yeah, as a general rule, you can go up and down one size and not have any concerns.
Somebody else asked, is there any issue with putting a biflow dryer in a straight cool system?
As a general rule, no. As a general rule, the only thing is you're probably reducing the capacity of how much you can filter and how much you can dry. Other than that, you know, if that's the only dryer you have access to, I definitely get it in and get that system running. Yes. It should not cause any, it shouldn't be any detriment to the system. It's just a reduced moisture and filtration aspect.
Yeah, you're paying more for something that you don't need in that case. Sure, exactly. And you're not getting as much out of it. What about double dryer? So this comes up a lot, the question about factory dryer is located inside of a condensing unit, and now you make a repair to the equipment, and it's going to be very inconvenient to replace it in the location that the factory put the dryer. What do you recommend doing in those cases?
Jim Fultz, do you have any input on that?
The short, easy answer on that is that you install your filter dryer there on the outside. If you are pumping down the condenser, you pull it out. I've not seen a lot of companies take the time to remove that filter dryer on the inside. Is it hurting anything? Do a pressure drop across it with some temperature probes and check it out. If you're within limits, you're good to go and keep going. If you don't have a degree temperature drop across it, I would not take the time or the effort to pull it out. But I definitely would be putting something new in the liquid line on the outside.
There's one caveat I want to give to this, and it's kind of a weird one, but there's a particular manufacturer who puts their liquid line dryers inside the condenser. And something you have to watch for is that you can have see, I didn't believe this when I first heard somebody say this, so it may not hit people right, but it was Joe Shearer who pointed this out to me, and we actually tested it on a live piece of equipment and did the whole thing. But if you have so much subcooling, so somebody overcharged the heck out of the system in order to try to compensate for a restricted dryer, you can actually have a dryer that's restricted on the liquid line and it won't show a pressure drop. It doesn't show a pressure drop until there's actually a change in pressure. I mean, it's there, but you won't see it as long as it's staying liquid. So if you're actually stacking liquid in that liquid dryer, you won't necessarily see that pressure drop. And that comes up. I've actually seen it happen a couple times since that conversation. And so the downside to that is if you leave it in because you don't see that temperature drop, you may run the risk of that really being the problem. Now you're going to see it in your system measurements. I mean, it's going to be very apparent that something isn't happening that it's supposed to be, but because it's happening inside of where you're measuring your pressure. So your pressure you're measuring here, and this is happening in the condenser where it's all stacked full of liquid. It's a tricky thing to troubleshoot just based on that alone. And that's where not having those pressure taps makes it tricky. So that's the one thing that I would say, when in doubt, change it out. And you can always cut out the factory one, straight pipe it, and then put your new Copeland dryer out on the outside of the equipment, or even better yet, by the indoor metering device. It's a tricky little thing to bump into. I actually ran the math on what the temperature change would be if it stays completely liquid and there's no phase change, and I thought it would be more than it was. It's actually a tiny amount. But again, that's a kind of a weird thing that doesn't happen most of the time.
That's actually kind of a new question for me. I've not been asked that. I'm sure we see everything out there, but I just believe in, gosh, do what you got to do to make the system right. And the system is designed for one filter dryer. I would do everything in my power to make sure I get one filter dryer. If I got to cut it out and put in just a piece of copper tubing in there and then put the dryer downstream, whatever. But that's quirky. So. Yeah,
and in the more extreme cases, you can always let the customer decide, so long as you fully communicate the cost differences for the different options that you provide. It makes the conversation challenging, obviously, but in some cases, that's what we're trying to do. We're trying to protect our clients from having to pay for a bunch of extra work that may or may not be necessary. But
sure,
those are some things that come up. There was one other question here that I wanted to address. Oh, well, one thing was a statement, which is a really good point. I saw this a lot early in my career. A lot of times discharge mufflers look a heck of a lot like liquid line dryers. So always make sure that you're not pulling out a discharge muffler and sticking a liquid line dryer in its place. That can be a pretty bad day. And I've actually seen that happen.
That'd be a real bad day.
Yeah. It's a real nasty cleanup. I think those are all the questions. I just want to make sure we got to those because some people may have to drop off, and I always like to make sure we get their questions answered. So now let's back into the question of kind of what's inside of a dryer, and especially that HH nomenclature. So there's different model numbers, and I think that's important to be clear, but you're looking for that HH at the end versus that EK. And those are different as far as what's in them. So talk a little bit about that.
Sure, Brian. So first off, the EK is our type of dryer, and then the HH so the EK is in the prefix. It's what we call our series of dryers. So we have the EK, the BSL, the BOK, and the CU on the liquid line side. The HH is an industry recognized suffix that tells you it has a third desiccant in there. And if you don't mind, I'll just back up and give a quick overview on desiccants. So Desiccants in the industry were designed to. There's three main desiccants. They are designed and they work by an adsorption, ADSORPTION, absorption. So they collect and hold on the surface. So there's three main desiccants. You have molecular sieve, which is designed solely to capture and hold moisture. Then you have activated alumina, which is designed to capture and hold acid. And then you had activated charcoal or activated carbon, which is designed to hold sludges and waxes and resins and stuff like that. So from the cost perspective, I think all major manufacturers in the United States, all like Copeland came out years and years, I'm talking 30 years ago, and said for POE, we want a 75-25 blend, 75% molecular sieve to capture and hold moisture, 25% activated alumina to capture and hold acid. Well, acid is only formed when you have too much moisture. So that's why we want more molecular sieve in there. Molecular sieve is also the most expensive desiccant. That's why a lot of, we'll just say unreputable brands will fill a dryer full of activated alumina, where it captures and holds acid. That doesn't do much as far as moisture, but it's a cheap filler. But all the major manufacturers do 75-25 blends on the desiccants, and then the activated carbon activated charcoal. When do you need this? When you have a burnout. You have, in the old days, I'm going to go back to the old days of mineral oil and alkylbenzene oil and such like that, R22. When you had burnouts back then, it created, the oil actually helped create a resin or a wax. So you needed that third desiccant, which is an activated carbon or activated charcoal, to go in there and attack those molecules that are in the system. In today's world, POE, everything, refrigerant, every 400 series refrigerant uses POE oil. And POE oil does not have the waxes and resins and sludges like the old mineral oil, alkylbenzene oil used to have. So Emerson's take, oh my gosh, hang on, Fultz slapped me. Copeland's take is for a burnout, the best bet is to use an EK filter dryer. Use it, run it, get it out, replace it with another EK, just keep sifting through the EKs. Again, waxes and resins are picked up through activated charcoal, activated carbon. If you have a system that has, mineral oil or alkylbenzene oil, then the stance is, yes, you probably need to go towards an HH type dryer. The hazards of putting an HH in a POE system that experienced a burnout, you're jeopardizing a little bit of the molecular sieve. You're jeopardizing some of the activated alumina that you need in there. You're paying a little bit more for the dryer. You're paying for activated carbon that you don't need. So it's a little overkill. We think the best bet is to just go after, if it's a POE burn, go after it with the EK, 75-25 blend, and just keep replacing it from that side. If you do have a mineral oil, alkylbenzene oil, or if you do have an isolated case, it could still happen, and you have some sort of a wax or resin in there, then you can look at putting a BOK in the liquid line side. So on the suction line side, it would be the ASK model, ASK with the HH suffix. So I don't know if that makes sense, but that's kind of the old school. When everything went to POE, it kind of changed our methodology. But we've had issues over the years with sticking TXVs, where people kind of panicked and, okay, I remember talking to a guy in Florida. He changed out like 6 dryers with HHs, and he said, it just won't clean up. And it's the HH isn't what's helping you. There was another issue in the industry at that point that caused those sticking TXVs. It had nothing to do with waxes and resins, so to speak. So it's a much debated. I was talking with Jim Fultz about this recently. Man, that is such a common question. It is, the industry is just perplexed with what to do with HH dryers. I know from our stance, Copeland stance is you just keep replacing with a good liquid line dryer. The EK would be the best bet to go after it. So does that make sense, Bryan?
Yeah, it's actually essentially exactly what Joe Shearer said when he was texting me before this presentation. So as usual, Joe is smarter than me, and turns out he was right. So that's good stuff. Fultz, any thoughts on that?
I think it's covered great. No, Hagl did a great job on that one.
Awesome. So a couple things that I also just want to mention quickly, because we're running up on time here. Whenever possible, when you're removing dryers, cut them out, don't burn them out, don't sweat them out, because it does cause them to release the moisture inside of them. And for Pete's sake, like, a lot of the problems that happen with equipment is because you just didn't pull a proper vacuum. You didn't follow proper procedures in the first place. If you purge, flow nitrogen, then pull a deep vacuum, that dryer's not doing much of anything anyway, because it doesn't have much to catch. It's when we're, running our line sets through the sand, and then we're not flowing nitrogen, and we're not pulling a good vacuum. That's when all this stuff becomes more of a factor. So best practices in terms of, handling piping, making sure when you're deburring, you're not getting copper shavings in the copper lines, not leaving the pipes open in a rainstorm, you don't open the system in those conditions. A lot of the really obvious stuff prevents some of the more edge cases. And a lot of the rest of it will work itself out. So any other best practices, things that we need to make sure to cover here before we wrap up?
You took the words right out of my mouth with best practices there. I was scrolling back through the comments and saw one asking about the crimp style of connection versus brazing. And my only comment from previous field experience is, if you go back enough years, Coleman made a system that the coil was charged, the line set was charged, and the condenser was charged. And all you had to do was thread the fittings together. They had O-rings in them. And within 5 or 10 years, every winter, when those fittings expanded from the cold, the refrigerant was leaking out with it. And most of the time, techs would go out and end up cutting those types of fittings with the seals out. What we have today with the style of fittings with the compression rings, time will tell. I've not been where I've seen them being used and seen results of that. So I don't know that I'm going to give an opinion one way or the other, just simply from the previous experience. The plus that I do like about it is the fact that you're not heating up that copper and creating the oxidation. And that is one thing that I've seen time and time again. And a lot of manufacturers deal with warranting brand new systems, TXVs, because the system was brazed closed without nitrogen. And then you got that oxidation on the inside of the copper, and those flakes go right to that TXV at startup. And there was nothing wrong with the TXV. It was a good, perfectly fine TXV. It's just the practice of not flowing nitrogen, that 5 pounds nitrogen when you're brazing. I can't stress that enough on putting those systems back together. And even with a filter dryer, if you're not, I'm putting a filter dryer in, so I'm protecting it. Well, you got two ends of the filter dryer. One end of the filter dryer where you braze without nitrogen, those flakes will go in the filter dryer. But what about the other end that's on the outside, the exit side of that filter dryer? They're going to head to the TXV. And you're going to be back out there dealing with that, or the homeowner's going to be dealing with a refrigeration issue that's going to be a challenge to try to figure out, is this thing fully restricted? Is it partially restricted? I've seen TXVs that a 3-ton condensing unit, and the coil, the bottom half bottom 2/3 is saturated. The top third has had no moisture on it for several years. And that was because of a partial restriction within that TXV. So do your homeowners a service. Make sure you're flowing that 5 pounds nitrogen, dry nitrogen through every time you pull out a torch. And you covered that well, Bryan. I wanted to hit that because I see that as one of the biggest things in the industry that we could see as an improvement.
Absolutely. So for people who need to find out more, who want to learn from you guys and the collective wisdom of Copeland, what are some best resources?
Well, kind of how we started this presentation is we're still working on cleaning everything up. But basically, if you go to Copeland's website, I think if you go to Copeland Products, and go under either air conditioning or refrigeration, you'll see a link on the side for brands being White Rogers. Best bet would be to kind of click on that. And then that'll take you right to online catalogs. That'll take you to cross-reference information, product information, videos, free training that we have posted out there on various products. Or if you have a specific question and you want to get a hold of our application engineering group for the cooling controls, good golly, Miss Molly, I have the phone number somewhere.
I'll go ahead while you're looking for that. If you can't find it,
Sure.
that's okay. But I created a simplified link for you to find out more on the dryer side for everybody out there. HVACRschool.com/Copeland-Driers. HVACRschool.com/Copeland-Driers is a place for you to go to find out more about the dryer line. And I'm sure you can easily make your way to the engineering team if you have specific questions. I did want to answer a couple questions came up. I want to answer just quickly. I know the answer on these, which is the questions came up about additives and flushes. There's pretty much nobody really wants you doing that. Now, for individual cases, the same thing is true of acid inhibitors or any of those sorts of things. Are there cases where it might work out for you? Well, maybe, but it's a crapshoot, and no manufacturer is going to say that that's a really good idea to apply across the board. I talk about this with aftermarket hard start kits, aftermarket this, aftermarket that. Sometimes it works out for you, but in most cases, it could do as much harm as good. And do you really know? When in doubt, doing a good solid oil test is going to be a better bet. That's something that you can go back to and kind of look at. Is the oil where it needs to be? Again, it's more practical on larger systems like market refrigeration or large AC. And smaller systems, that can be very difficult to do. But that's really the answer, is that doing a good solid dryer cleanup and following best practices, going back and pulling out those dryers, putting in nice fresh clean ones every time you service the equipment, that's going to be your best bet all the way around. I'll let you guys comment if there's anything else you wanted to add. I just wanted to quick answer
that's pretty
those.
it. You've hit that nail on the head. At Copeland, we don't make flushes and additives and all that stuff. We design our stuff to work and operate, and we believe doing the old-fashioned method, what you just mentioned right there, testing oil and changing out dryers is the way to do it. But to each their own. You don't know if there was some other guy last week that was in there trying to work on that same equipment and threw in three different things. You don't know what you're creating in there. So, you're gonna hear that from us, that we're not going to be big fans of trying to get the shortcuts or the fix a flat, if you will. So
certainly.
Yep.
All right. Well, Jim and Jim, Copeland, thank you guys so much for participating in this. Everybody who asked questions, we're going to keep this video up. We'll probably do an edited version up on the different platforms. Everybody who asked questions, always really appreciate that. And big thanks to Copeland for being a partner with us at HVAC School. It means a lot. Training is important. Keep doing the best thing out there, guys. And we will see you all again very soon.
Thank you.
Thanks,
Brian.